Okay, Algebra 2, we are going to go through these two documents. First of all, as you can see, you should have this worksheet out on radicals, which I just handed out to you, Parker. And second of all, you should have a blank sheet of paper. And here's what we want to start by doing. We need to make a list of perfect squares, and we need to make a list of perfect cubes, and a list of perfect fourths, so on and so forth. So, on a blank sheet of paper, I want you to write this down. You don't have to write that. So, boys. Okay, so guys, stop taking his paper so he can be quiet and focus on this, okay? So, here we are. We need to make a list. And we're going to first make a list of squares. Now, I don't have the ability to write as long as you do on your paper, so however you want to organize this is fine, but we're going to do squares, cubes, fourths, fifths, so on and so forth, okay? And we're going to start by listing some of the perfect squares. One squared is 1. 2 squared is 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And 10 squared, 100. However, there's a lot more perfect squares than that, and we're going to list a few more. Okay? We go to 11. 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. 16 squared, 256. 17 squared, 289. 18 squared, 324. 19 squared, 361. And 20 squared, 400. And you might want to stop there. We should write down 5 more. So now Parker's using a calculator, but after a while you should remember these, as many of them as you can. 441 would be 21 squared. 22 would be 484. 23 would be 529. 24 would be 576. And 25 is 625. So that's a list of perfect squares. Now the list of perfect squares up to the number 25, 625, that's the most exhaustive of them all. We're not going to list nearly as many for cubes or fourths. Everybody got that? Oh, where you at? Okay, we'll write these down. I'll give you another second. Let me pause the video. Okay. Let's try another one. Cubes. One cubed. 1. 2 cubed. 8. 3 cubed. 27. 4 cubed. 4 times 4 times 4 is 64. 5 cubed. 5 times 5 is 25. Times 5 more is 125. 6 cubed. 6 times 6 is 36. Times 6 more is 216. 7 cubed, 343. 8 cubed, 512. 9 cubed, 729. 10 cubed, 1,000. Spend a little bit more time, we'll just look at fourths. So you can see that when you cube something, it's bigger a lot more quickly than the squares. So we get to 1,000 much more quickly with cubes. So for fourths, what's 1 to the fourth? 1. 2 to the fourth? 16. 3 to the fourth? 3 to the fourth will be 81. 4 to the fourth? 4 times 4 is 16, times 4 is 64, times 4 again is 256. 5 to the fourth? And we'll stop there. So those are perfect fourths. So the fourth root of 81 is 3. The fourth root of 256 is 4. The fourth root of 625 is 5. That will help us complete our task today because we want to work with radicals. And instead of... Okay, so we want to deal with radicals. And before we've just dealt with square roots. Well, if you look across this section right here, we have cube roots. We have fourth roots. We have more square roots. And so we're going to deal with all those type of things and start to reduce them. Let's try to do what we've done in the past. We look at the square root of 48. Can you think of a perfect square, as you look at this list right here, a perfect square that divides evenly into 48? Very good. 4 and 12 works, but there's a larger perfect square that divides evenly into 48. 16. Now, let's do it Garrett's way. Garrett said 4 and 12. What I do is I can rewrite radicals as multiples of one another. So I can rewrite this as the square root of 4 times the square root of 12. Now, you write the one that you can take the square root of first. What's the square root of 4? 2. 2 square roots of 12. Now, I'm not done. And that's why I said we should choose the larger one. In this case, you've got 2 square roots of 12. Is there a perfect square that divides evenly into 12? 4. So you would do it again. 2 times the square root of 4 times the square root of 3. What is the square root of 4? 2. And 2 times 2 is 4. So we have 4 square roots of 3. Now that's what Garrett told me to do right away, and there's nothing wrong with that, reducing it more than once. However, you could have reduced it right away by writing the square root of 16 times the square root of 3. 48 is equal to 16 times 3. And you know the square root of 16, it is 4. So you have 4 square roots of 3. Okay? See if you can do number 2 and number 3 on your own. Try that right now. Okay? Try number 2 and 3 on your own. I'll let this run so that 8th hour, you guys go ahead and give those a try. You, by the way, you should be in your seats. If you're not, you're absent. You guys know the deal. And again, if you're trying to look where to go, I'll give you a couple minutes to look through these. You look for the perfect square that divides evenly into those. And we have a list of perfect squares right here. So Okay, let's try number 2. What'd you get? How'd you rewrite this to start out with? How'd you rewrite it to start out with? Square root of 4, square root of 7. And Casey, what'd you come up with? 2 square roots of 7 is correct. Square root of 125. Very good. You have 5 times the square root of 25. I'm sorry, square root of 25 times the square root of 5. That's how you get 125. So 25 is the perfect square that divides evenly. It goes in 5 times. Square root of 25 is 5, so you have 5 square roots of 5 in the end. That's what you get. Now, here's where it changes, okay? Now we have cube roots and fourth roots, okay? Cube roots and fourth roots. Well, when you have a cube root, you do it the same way. Here's how I set it up. I write this as the cube root of something times the cube root of something. So I need 2 numbers to place in here that multiply 16, and one of them has to be a perfect cube. 4 is a perfect square, but not a perfect cube. 8 is a perfect cube. So I'll put 8, and I'll put 2. Now again, I got the 8 from looking at this list right here. I looked at cubes, and I found 8. So that's why I chose to use that one. And now we simplify it from there. What is the cube root of 8? 2. And so we write it as 2 cubed roots of 2. Whoop. There was a question over here. Serena? No? Anybody? Okay. Number 5, we have a fourth root. As you look at the number 162, this is a little bit more difficult. As we look at the perfect fourth roots, I'm going to pull it up here. Number 1, number 16, 81, 256, 625. Do you see one of these that divides evenly into 162? 81 goes in there how many times? Twice. 81 times 2 would be 162. And if you don't know it, then you got to manually check. You got to take 162 divided by 81, divided by 16, divided by 256, and see what comes out correctly. But 81 goes in there twice. So what I could do is I go to my problem. I rewrite this. Instead of the fourth root of 162, I rewrite it as the fourth root of something times the fourth root of something. And underneath there, I could put the fourth root of 81 times the fourth root of 2. Because 81 times 2 is 162. What is the fourth root of 81? 3. So you have 3 fourth roots of 2. Now I know that looks strange, but that's what we have. Okay? That's the answer. I'm going to give you guys a few minutes here, all right, to try 6, 7, 8. Actually, why don't you right now work on problem 6, 7, 8, 9, all the way through 12. Work on these. And as you have an answer, come to the board and put it up there. So 8th hour, I'm going to let this video run. You guys start right now. Try to answer these. And as 3rd hour people get some of these correct, they're going to come up here and see if they can put up the answer. Do the work just like I did, okay? Go ahead. See if you can do it. Go. Okay, all right. It looks like you guys took us through those spots. Good job. So that's how we reduced them, and everything we did here, we did with just numbers. Now what I want to do is I want to work with variables. And this might look a little bit more difficult than it should be, but now we're going to work with some variables. So I have the square root of 25x squared. And so you work with the numbers, and then you work with the variables. So what times what is 25? 5. And what times what is x squared? X. Now, 49 you got, or 14, you got 49 x to the fourth, y to the, I can't read that, is that eighth? So what times what is 49? 7. What times what is x to the fourth? X squared. And what times what is y to the eighth? Y to the fourth. So as you look at that, what did you do with the exponents? You divided them by 2. So if you're taking a cubed root, what do you think you'll do to the exponents? Divide them by 3. If you have a fourth root, you'll divide them by 4. And that's how we will navigate. Okay, so let's do some of the rest of these here. Okay, a squared of 100, a squared b 10, c to the 6. 10, a, b to the 5th, third. Yep, because you divide the exponents by 2 when you take that square root. Very good. Cube root. So I got to think about the cube root of 8. Cube root of 8 is 2. Cube root of 8 to the third. So what times what times what is 8 to the third? Just a. You're right. You take that exponent and you divide it by 3. So it will be b to the second. Very good. So you can take your exponents and you can divide them by the index number, whatever you want to call it. The root number. See if you do the last two on your own, okay? Take a few seconds here and work out 17 and 18. Think them through. If you need to look at your sheet, you need to look at your sheet. Give you about 30 seconds, and then I'll put the answers up here. And we'll try some that are a little bit more difficult. Yep. There's harder ones than these, so we're going to get to the final part here in a second. Okay, who's got 17? What do you got? I think the fourth root of 256 is 4. Yep, x, y squared, z to the third. Yep, that's what we should have. So fourth root of 256 is 4, and I divide my exponents by 4. 125x to the 6, you got? Very good. Okay? Now, those all worked out perfect. On the back side, that's not going to necessarily be the case. So let's flip it over and see what happens on the back side. My bad, that radical for number 20 should carry across the whole way. 19, 20, and 21 I put so that they work out real nice, but you guys could do those on your own, okay? So 19, 20, and 21, we're going to leave those for you as homework. Those are easy problems, okay? Let's do a couple that are harder, and you're going to have to finish off then the rest of this piece here. So let's look at problem 22. Is there a square root of 32? No. And so what I have to do is I have to divide it into two pieces, and I work with my numbers first. What's a perfect square that divides evenly into 32? 16. And then I have 2. All right? Now you can see I left some space because now I have to work with my variables. Let's look at x to the third. Is x to the third divisible by what? What do we need x to the third to be divisible by? 2. It's not divisible by 2, is it? Because this is again a square root here. Okay? So x to the third is not divisible by 2. So I reduce the power by 1. Is x squared divisible by 2? Or is 2 divisible by 2? Yeah. So I can put an x squared here. What do you think I have to put over on the other side? The other x. Yep. And I move to my y squared. Is 2 divisible by 2? So I put the y squared here. What do I put on the other side? Nothing. So notice that if you were to take the right side, the left side and the right side and multiply them together, you would get everything underneath here. That has to happen all the time. The difference is what you see on the left side, I could take the square root of that. What's the square root of 16x squared y squared? 4xy, and then I have the square root of 2x, and I just leave that there. So notice how at the beginning of class we started by doing easy problems that just involved basic numbers, and we simplified those radical expressions. Now they have variables, and that's how we do it. Let's try another one with the square root, and then we'll try cube root here in a second. Okay? Let's try number 24. Let's try 24 together right now. Is there a square root of 50? There isn't, so I divide it up into two pieces, and I heard somebody say 25, so 25 and 2. X to the fourth. Can I take the square root of x to the fourth? Is 4 divisible by 2? Yes, so I can have x to the fourth underneath here. Is y to the third? Can I take the square root of y to the third? No, so I have to divide it up into two pieces. What do I divide it up into? Y squared and y. Very good. Square root of 25x to the fourth y squared is 5x squared y times the square root of 2y. Very good. Very good. And 8th hour, as you guys are watching this, if you need to see something again, you can obviously pause the video and re-watch it. Okay? No problems there. Let's try two more, and then you guys can do some homework. Let's try problem number 28, and let's try problem 29. Okay, we'll do those two. You guys can go from there. All right. Cubed root. Is there a cubed root of 24? No. So I'm going to have to break this into two parts. Cubed root of something. Cubed root of something. What is a perfect cube that divides evenly into 24? 8 and 3. Very good. So I put an 8 there. I put a 3 there. Now I look at my exponents. Is 6 divisible by 3? Yes. So I put an a to the 6th. Now I look at my b. B to the 5th. Is 5 divisible by 3? No. So I decrease it by 1. How about 4? No. So I decrease it by another one. How about 3? Yeah, so I can put a b to the 3rd underneath here. What do I put over on the other side then? A b to the 2nd. Very good. So that will give me my b to the 5th. And then c to the 4th, I can't do that, can I? So I should have c to the 3rd and c. So what's the cubed root of 8, a to the 6th, b to the 3rd, c to the 3rd? Close. 2a squared bc times the cubed root of 3b squared c. Let's try one more. Any questions on 28? Gotta follow that step process each time, guys. That 3? Right there? Because the cubed root of b to the 3rd is b. Just like the cubed root of a to the 6th is a to the 2. I divided those by 3. So, let's do the last one. Is there a 4th root of 32? I can do 16 and 2. So I have to make two separate radicals here. And I have 16 under one, and I have 2 under the other. A to the 7th is 7 divisible by 4. How about 6? 5. So I have to go all the way down to 4. So I have an a to the 4th. What goes on the right-hand side then? A to the 3rd. B to the 4th is 4 divisible by 4? Yes. So I have a b to the 4th right here. What's the 4th root of 16? 2. What's the 4th root of a to the 4th? A. Fourth root of b to the fourth. B. We're going to fourth root of 2a to the third. Okay, I know that it's not easy right away, but I think that we've covered some ground. I want you to try working through as many of these problems as you can. Again, I left you 3 up here, and I left you some others around here. So you got some square roots, you got some third roots, some fourth roots. Do your best to work through that. That's your assignment. Looks like you probably got, 8th hour, you probably got about 10, 12 minutes. You guys got about 5, okay? So continue working. Yep.